Good evening, everyone. I'm Associate Professor Joe Ford. I'm the Associate Dean International for the ANU College of Law. So I'm very delighted to welcome you to this evening's virtual discussion, Taming the Terminator, Law, Ethics and Artificial Intelligence. A very warm welcome to our audience and participants who are around Australia and indeed the world and the region. It's my honour to acknowledge and celebrate the first Australians on whose land we, at least here in the ANU, are gathering today, and to pay our respects to their elders, past and present. 2020, of course, has been an interesting and difficult and remarkable year in many ways and for many reasons. But for us here at ANU Law, it also marks an important milestone, which is 60 years of law teaching and law research at the ANU. So to celebrate this across this year, and using this sort of technology, we've presented our Law in Focus program of events, thought leadership, research and analytical events, bringing together the rich scholarship and work of our legal scholars, some of our alumni, and those in the wider ANU Law family. This is the final event in that series, and we're shifting to a highly topical issue of the intersection or nexus of law and technology, from artificial intelligence and automation to blockchain and cryptocurrencies. We're living, as you all know, in a world of rapidly changing realities. Tonight's panel, highly qualified, will examine some of the implications of these developments for us and for the law and for lawyers, and the associated legal and ethical challenges. And no doubt one of the questions is whether these issues are best approached as questions of law or as questions of ethics, or some lovely smart mix of the two. So I'd like to introduce Dr. James Popple, Official Secretary to the Royal Commission on Aged Care. Dr. Popple is one of our own here as part of the ANU Law family that I mentioned. He's an alum of the ANU Law School and an honorary professor. He was also Australia's inaugural Freedom of Information Commissioner. He's going to moderate tonight's discussion and to introduce the ANU and other experts as part of it. So over to you, James, and thank you very much.
Thank you, Joe. Look, it's my very great pleasure to be moderator for tonight's discussion. We're going to explore, as you've heard, the complex legal and ethical challenges that AI and automated decision-making present to industry, government, and the legal profession. And tonight's event is part of the College of Law's 60th anniversary celebrations. I did the maths just before we started. It is not 60 years since I first arrived at the ANU Law School. It just feels like it. But first, some housekeeping. This webinar is being recorded and will be available on the multimedia section of the ANU College of Law website and the YouTube channel later this week. In a moment, we'll hear from each of our panelists. Then we'll have a question and answer session. You can join in the discussion by asking your questions using the Zoom Q&A function. You can ask a question at any time. Please specify if your question is meant for one of our panelists in particular, and I'll put as many of those questions to our panelists as time allows at the end. So let me introduce our panel. First of all, I'll say that all three of our panelists are connected to Humanizing Machine Intelligence, which is a multidisciplinary research project funded by the ANU Grand Challenges Scheme. It explores automating governance, algorithmic ethics, human AI interaction, and much more. Our first speaker will be Dr. Will Bateman. Will is a senior lecturer at the ANU College of Law. He leads multi-jurisdictional projects on the legal regulation of public and private finance, with a special focus on central banking, sovereign debt markets, national budget formulation, and sustainable investing. He's had recent engagements with central banks and financial regulators, including the Federal Reserve Bank of New York and the Bank of England. Will leads research projects on the regulation of artificial intelligence and is currently spearheading a major project on the formulation of model legal frameworks to govern artificial intelligence in the public sector. Dr. Tiberio Caetano is Chief Scientist at Gradient Institute. He's a machine learning researcher and leader, having worked in Brazil, Canada, France, and Australia. He worked as a researcher at NICTA, now Data61, for 10 years. He's published extensively in the field of machine learning. He co-founded Ambiata, later acquired by IAG, where he led the design of decision-making algorithms. Recently, he helped establish Gradient Institute, which is a not-for-profit research institute focusing on ethical AI. He works on incorporating ethical considerations into the technical designs of AI systems. Tiberio is an adjunct professor at UNSW, an honorary professor at the ANU, and an advisor for the OECD on AI. And lastly, Dr. Atoosa Kasirzadeh is a research fellow at the Humanizing Machine Intelligence ANU Grand Challenge Project. She works at the intersection of philosophy and sociology of science and technology, individual and group decision-making, and artificial intelligence. She has a mathematics PhD on the optimization of large-scale decision-making problems, and she's clearly a glutton for punishment because she is currently finishing her second PhD, this time in philosophy, where she tackles the contribution of mathematics to the explanation of social and natural phenomena, and the implications of this contribution to specifying the scope of explanatory reasoning for AI. Now, each of our panelists is going to speak for 10 minutes, after which we'll open up the discussion to your questions. And our first speaker is Will.
Thank you so much, James. And it is a real pleasure to be introduced by Dr. James Popple, who was one of the ANU's trailblazers in law and artificial intelligence. Dr. Popple wrote a PhD where he proposed, coded, and created a legal expert decision system called Shyster, an automated legal advice program, which I read very carefully when I was gaining my own law and AI stripes. I'll be speaking today on two topics. The first is what I call the legitimacy crisis in public sector automation, democratic authorization of algorithmic decision-making. The second is central bank digital currency, using technology to socialize monetary policy and monetize social policy. Now, both of those topics are academic mouthfuls, and I think they're best approached through concrete examples. Jumping into the first one, what I call the legitimacy crisis of public sector automation. We are all immensely aware of a series of high-profile scandals concerning the rollout of advanced technology by various government agencies around the developed and developing world. In Australia, we've been treated over the past several years to a rolling front page news story called the Robo debt scandal, which was a series of complicated and ultimately legally unauthorised automated debt collecting services operated by the Commonwealth Government. But Australia is not an outlier in the existence of these relatively high profile scandals. The United States has had a ongoing governance and public and media scandal around the Compass algorithm, which is an automated machine learning algorithm which assesses criminal recidivism risk, which is used in the United States criminal justice system. And throughout Europe and North America, and also in Australia, automated facial recognition has produced, the use of automated facial recognition by law enforcement agencies has produced a fair share of controversy. Now, in one sense, each one of these scandals, and I'm trying not to be journalistic, but they are scandals, Robodebt, Compass, and automated facial recognition could be understood as a governance failure. Discriminatory against certain groups, whether vulnerable welfare recipients or people of various people with protected attributes, race, gender, etc. Or they could just be understood as illegal or invasive of people's privacy. My contention is that each one of these scandals indicates a deeper problem that can be addressed in a constructive way, concerning the lack of legislative authorization for what is a force multiplier for government power, the use of algorithmic decision systems. Now, it's immediately obvious to academics why it's important to have legitimate government power and why legislation creates legitimacy around the behavior of government agencies. It's not necessarily so obvious to ordinary people why the enactment of legislation provides an obvious and important basis for fair and predictable and consistent government decision making, but it does. Modern government, as we understand it, and as the public sector operates, is built on parliamentary legislation, which is enforced by courts. Legislation, although it is distant from most people's ordinary experiences, provides a basic framework for legitimate state power. It doesn't mean that state power is always legitimate. It doesn't mean that it will please everybody or that will always be fair, but voting, deliberating on legislative proposals, and making sure that the important work performed by public officials, it occurs within a predictable framework governed by parliamentary legislation, is a tremendously important precondition to the type of modern government that modern society that we live in today, and modern government which rules it. Now, algorithmic decision-making, the use of algorithmic systems by government agencies, can be understood as a force multiplier of government power. Algorithms can make decisions that humans find very difficult in much faster timeframes, in a vastly scalable fashion. They are cheaper to operate compared to paying ordinary humans to stamp pieces of paper and walk them to and from different departments all over Canberra. And they're also, algorithmic decision systems can be coded in such a way that they can make precise and careful measurements that humans find tremendously difficult to make, at least in a fast fashion. Of course, people can also say computer systems can be dumb, slow, and error prone, and that is of course true. But the reason algorithms and algorithmic decision-making is attractive to, say, the Australian Federal Police, or say the Department of Human Services, or the Department of Health, is because it improves the experience of government, both from the position of the public administrators who operate departments in terms of meeting budget constraints, meeting key performance indicators, and also from the perspective of people who engage with government. Think how much easier it is to fill out a Medicare rebate slip through the MyGov app as opposed to lining up at storefronts around the country. Now, Robodebt, Compass, and the automated facial recognition scandals show how algorithms and algorithmic decision-making has snuck into government without widespread legislative support for the use of these advanced technologies. And if there isn't widespread legislative authorization, there hasn't been widespread parliamentary debate, and there hasn't been the opportunity for political parties to formulate policies and positions based around their use of these tremendously powerful technologies. There have been steps in the Commonwealth government and in the Commonwealth legislature to provide some measure of legislative authorization for the use of technologies like algorithmic decision-making to exercise public powers to say, grant you a visa if you're somebody who's arrived in Australia who's not a citizen, or say to determine whether or not you do receive a welfare benefit. But that legislation is embryonic and needs to be significantly developed before it answers the description of a meaningful and legitimate framework for the use of these advanced technologies by governments. Australia, in many respects, is a leader in this field. At least the Commonwealth government is. The Australian states have almost no legislation supporting or authorising the use of algorithmic decision-making by their public sector agencies, and that represents the global trend in which there isn't meaningful parliamentary engagement with the sorts of circumstances in which it is appropriate for public officials to use algorithmic systems to exercise their powers, which can benefit and can significantly harm citizens. The second topic I'm going to speak on in the remaining time is central bank digital currency, using technology to socialize monetary policy and monetize social policy. Now, that's another mouthful, but it basically means on your smartphone, instead of in your wallet, you will have notes and coins issued by the Reserve Bank of Australia, which will come as a relief to anybody who goes jogging or has trousers they don't want to ruin with a wallet line anymore. Digital currencies issued by a central bank to replace notes and coins are coming very quickly and will be available by the end of 2021, the beginning of 2022. Now, it's hard to know exactly what a change like this has to do with technology. How does having a digital wallet on your phone, as opposed to a physical wallet in your back pocket, significantly implicate automation of government or automation of society? Central bank digital currencies will almost certainly use relatively simple ledger-driven technologies, and they'll be operationalized through very familiar hardware systems like smartphones. But central bank digital currencies create the opportunity for extraordinary positives and negatives from the perspective of individuals engaging with government. On the negative front, there's concerns about privacy. The Reserve Bank or the central bank will be able to track individual transactions, which causes an obvious set of anxieties for privacy advocates. But there are significant positives to something like central bank digital currency, which shows the enormous positive and constructive impact of technology. Most importantly, central bank digital currencies will be able, if deployed properly, to address the drivers of wealth and income inequality. One of the reasons the People's Bank of China is so interested in central bank digital currencies is because it is so concerned with preventing tax evasion and capital flight. And from the perspective of large-scale corporates and the very complicated tax evasive structures which they use, the ability for the Reserve Bank to data match with revenue officers and tax officers and payroll officers, transactions will or can lead to very significant positive redistributive effects in welfare states. Again, this is a very complicated area and one where significant social and legislative discussions will need to be had, but it does show that we're not just taming the Terminator may be taming us. And I believe that my time is almost up.
Spot on, Will. Thank you for that. Our next speaker is Tiberio.
Thank you very much, James, and thank you for the law school to be, inviting us to be part of this exciting conversation. And congratulations for the 60th anniversary. That's great. I'm not there yet. I'll be there in a few years' time. Thank you, Will, for actually paving the way for what I wanted to talk about. Your first item on the legitimacy crisis of public sector automation. Maybe I will speak a little bit to that from the perspective of someone who has been working in the design of machine learning algorithms for about 20 years now. But I would like to take that conversation beyond the public sector and really talk more broadly about both public and private sector automation, and in particular, the use of automated decision-making, essentially shifting decisions that in the past were exclusively within the realm of human cognition to computer systems that today are deliberating on our present and future. Today, it's just a fact that banks, insurance companies, media companies, telecommunications providers, governments, and a variety of other service providers in industry and government all over the world, they are using data and algorithms to make consequential decisions about people's lives, okay? Whether you offer a job interview or not, whether you offer a loan or not, whether you offer insurance or not, today is mediated and influenced by algorithms that learn from the patterns of other customers, other people, not only from your patterns, connects everything together and tries to make a decision that advances some purpose set by the organization deploying the system, right? So this is just a fact. The question is, right, how good are these decisions? Number one. Second, how do we define what good is? And third, how do we try to improve the quality of those decisions based on those answers to those two previous questions? Now, it has become clear over the past few years that although the quality of many of these decisions is actually high on some metrics that are easy to be measured, to be quantified, like things that directly map to numbers, like revenue, profit, cost, right? Those things have immediate numerical codification. And those things, as a result, have been the things that people have been measuring over time. And those things have been the things that governments and businesses care about. Let's reduce costs, let's increase revenue, and so on. Government also wants to improve the lives of people, but it's really hard to measure what well-being actually is, right? Now, it turns out that there are lots of things that truly matter that are really hard to put in numbers. Fairness matters, dignity matters, well-being matters, freedom matters. And if you look at law today, we are talking with people from the law universe. It's not usually the universe I talk to, often talking to computer scientists, but law is largely, in one way, from a computer science perspective, an attempt to try to really navigate this complexity of these constraints that we need to navigate in order to ensure that sort of, the world sort of functions in a way so as not to significantly negatively affect on all those important things that aren't easy to quantify. Now comes AI. We are using AI to make these decisions about whether you get a loan or not, or whether you get your welfare payment is going to be X or Y, as per previous references that Will made to one particular system deployed by the Australian government, and in terms of debt recovery. Now we have a big problem. And the big problem is, if you are talking to a computer, if you're telling a computer to make a decision, and if you want that decision to be a fair decision, you want that decision to be a decision that doesn't adversely impact on the dignity of people, and you want that decision to be a decision that celebrates their autonomy, self-determination, and freedom, you want that decision to be a decision that promotes their well-being, you've got to transform all those words into mathematical code. Good luck. That's what we try to do, for example, at Gradient Institute. That's what many mathematicians and computer scientists are trying to do all over the world. They're trying to, in one way or another, convert or encode notions that the law and the ethical reasoning have historically dealt with, and try to somehow map them into a language that computers can actually understand. And that's extremely hard. So yes, there is the challenge that Will alluded to. How do we ensure that the traditional mechanisms of, liberal democracy with constitutional liberal democracy and so on, they are properly effective, they are properly used and applied in light of this world of automated decision systems. But likewise, we will face this wall. We are facing this wall, which is how do we essentially teach machines to be fair, to respect dignity and so on. We need to encode those things in numbers. Now, so that's one big challenge that we and many other people are working on. And clearly, as you see from this, it's not a challenge that can be solved or addressed effectively by just technologists. Will and I, we collaborate. Will is a fellow of Gradient Institute as well. And we are trying to sort out these questions from a multidisciplinary perspective. There's no way I can see to address effectively these complicated questions we are living with without a multilateral, multi-perspective approach. Now, it is also the case that we won't be able to necessarily solve these problems perfectly, right? And what do? I mean, I like secular Buddhism, and the Buddhists, they like to say that, there are two things you need to do in life. You need to really try to control those factors you can control, and you need to try and accept those factors you can't control. So let me just change that a little bit. So you want to control those factors you can control, like design the technology so that it's fair, it's equitable, and so on and so forth. But you also want to buy yourself some sort of insurance, right? or create protections and create systems that sort of compensate for the inexorable mistakes, the inexorable faults that any AI system will make. Just like we have systems that, institutions and systems that actually do that for human decision making, we should do the same for machines. It should be no different. Now, how to do that? It's a complicated question. And I'll just leave you perhaps with one thought. You know, when people ask me, what do you think legislation should be doing in this space? I say, well, obviously, I'm not going to give you a good answer because I'm not a legal scholar. I'm a physicist, a computer scientist, I understand mathematics and so on, but I do not understand law. But what I can probably give you is perhaps a clue about a property of some legislation. There's one property that perhaps you want some legislation to have, which is, if this legislation was enacted 50 years ago, would it be affording the protections that we need now? Now, if the answer is yes, then you're probably talking about a kind of a piece of legislation that 50 years from now will be also surviving the technology we'll have then. Now, it's really important to think about the unintended consequences of law. In fact, you know, one of the corollaries of the law of unintended consequences is the unintended consequences of law. So when people are thinking about legislation, I would strongly encourage thinking in terms of robustness, thinking in terms of, you know, what would have worked today had we designed it 50 years ago with information available then. This is just a little bit of a thought to leave the legal scholars in the room thinking about it. And I think this kind of concludes my 10 minutes, and I'll pass back to James. Over to you.
Thank you, Tiberio. Thank you very much. Atoosa is our third and final speaker.
Okay, thanks very much, everyone. Thanks, James, for inviting me to this panel, and Will and Tiberio for paving the way for me to talk more about one particular philosophical analytical challenge that relates definitely to discussions about the ethics of artificial intelligence, but also the design of legal framework and legislations. So by now, everyone agrees that some sort of ethical and legal conditions and constraints for the use and design of AI systems are required. But as Tiberio also pointed out to this problem, how to achieve this is one of the most challenging problems. And one of the core challenges that I want to specifically talk about today, which can be broadly called the translation problem, is about the issues that we face in an appropriate and effective translation of higher level legal and ethical concepts and languages into more technical ones. The translation problem basically shows that the effectiveness of the ethical and legal regulations might not always be guaranteed, or even in some contexts, we might think that we have some ethical frameworks and legal frameworks that somehow try to tame our AI systems and kind of prevent more and more scandalous situations. But indeed, because of the translation problem, these legal frameworks and ethical frameworks might not be very helpful. So in this talk today, I want to talk about two particular examples, two very famous ethical principles that always come up when you think about ethical AI or like different ethical and legal frameworks for AI, for the design of them, that this translation problem basically shows there are some central challenges to the design of these ethical and legal frameworks. So a variety of legal and ethical frameworks take fairness to be a core principle of an ethical AI system. Almost all of the ethical frameworks actually refer to the conception of fairness. So for example, in Article 5 of General Data Protection Regulation, among other things, there's a principle about the processing of personal data. There are actually lots of principles. One of these principles is the principle of fairness, which again, in English language, it says that personal data should be processed fairly. But what does fairness really mean? And how should we build a fair data set for an artificial intelligence system? Or how should we ensure that the algorithmic methods that process data guarantee the preservation of fairness? So there are many definitions of fairness coming from economics literature, legal literature, philosophical literature, and by many in the context of algorithmic fairness, I'm talking about something more than 40 definitions. I don't have time to go and talk about all of them, but I'm going to review a few of them just to give you a feeling of what this translation problem really is. So one way of interpreting fairness, maybe the most straightforward way, is to say that fair data processing must be such that no mention to the sensitive attributes such as gender or race should be included in the set of features that a data set is going to represent. This notion of fairness actually is often called fairness through blindness, and this conception sounds very appealing, and it's very easy to use, and there's lots of legal support for it. The idea would be that when many decisions are made about hiring, about like giving loans, then there shouldn't be any discrimination based on any of these sensitive attributes. However, in practice, when we come to talk about the context of big data and artificial intelligence, this conception of fairness, or this measure of fairness appears to be very ineffective and harmful. And again, remember, we are talking about massive data sets with millions or billions of data points that are capturing the quantified life of people. So a lot of what we may call actually non-sensitive attributes, say a person's browsing history, whatever you search on Google or any other search platform, might end up actually being highly correlated with one of these sensitive attributes, for example, gender. So a typical browsing history, of course, includes numerous non-sensitive features. And then when they become slightly predictive of the sensitive attributes, then even if you don't talk about sensitive attributes directly, and you think that you are enforcing a notion of fairness without reference sensitive attributes, this approach or this incorporation of fairness is not going to be very effective and helpful with respect to like big data and artificial intelligence. Of course, fairness can be interpreted in many different ways, because here we are talking about like large data sets, and there's always probability theory and statistics up front. Then maybe we want to think about some statistical notion of fairness. So for example, let's consider a predictive algorithm which wants to kind of process data fairly, given that we can't in practice achieve 100% predictive accuracy because we don't know about the future and there's an inherent uncertainty associated with the future. We might aim for obtaining at least some degree of accuracy across different groups. So if you think about the case of COMPASS algorithm, one of the scandals in the United States, we might, for example, think about having the same degree of false positive rate among Black defendants and white defendants if the predictive algorithm is this risk assessment tool for predicting the risk of reoffending crimes. And we might assume that considering the equal rates of false positive or false negative actually would make the algorithm fair and would make this data processing fair. But again, when we try to end up translating different ways that capture the notion of accuracy or having the same accuracy across different groups, mathematically speaking, we are going to end up having many different mathematical measures. And you might want to say that actually we can satisfy all of these measures. Let's do that. Let's satisfy all of these measures. But unfortunately, there are some very interesting and elegant mathematical technical results that show that it is mathematically impossible to satisfy or to guarantee all of these notions of fairness, statistical fairness, simultaneously. So what does this mean? It means that even if we say in English words, or we just write in our ethical frameworks or legal frameworks that we really want to design a fair system, a fair AI system, it might be that on a technical level, this translation of our conceptions of fairness with English language would become super difficult, and actually we might not really be able to do that. So this is a challenge, I don't want to be very pessimistic, but I just want to say that we need to really acknowledge this very important challenge right up front, and then we need to kind of work through it in interdisciplinary groups. Another ethical principle, in addition to fairness, is the notion of, or the issue of, algorithmic transparency. And in particular, with respect to machine learning algorithms, and those algorithms that basically are based on some deep neural network structures, this issue of transparency is kind of like inherent. And so people try to say that maybe because these algorithms are very opaque, it means that we cannot, with our cognitive capacities, understand or capture what is happening in the algorithm. We just can see the output. Then maybe we have to kind of make these algorithms explainable. So we have to design some methods such that not only these algorithms generate output, but when they generate output, they also explain how this output is generated. So because of this transparency principle, which is one ethical principle, many academic and industrial research programs have been put into operation to develop the so-called explainable AI systems. And again, the development of this explainable AI system is motivated by many different social and ethical reasons. And again, for example, in GDPR, there is a kind of a like reference to the notion of explanation. And then there's been a very huge discussion about whether GDPR and this reference to explanation principle kind of imposes that there should be a right to explanation. There's been like a super exciting discussion between legal scholars, social scientists, philosophers about this. But again, one very important analytical or philosophical question here is like, what do we really mean by explanation? What is a helpful explanation? And then, of course, how a system is going to generate this explanation, and then how we can ensure that this explanation like shows the true reasons that the system has basically used in order to make decisions. So computer scientists have basically identified that there is no well-formed definition of AI explainability as an all-purpose monolithic concept, but they have developed many different methods for making AI systems explainable. For example, AI systems might generate a local explanation, which is a kind of an approximation for how this super sophisticated, complicated system has worked in order to generate this output. So as you know, or as I know, basically, because I faced with this situation, there's been like many banks in Australia actually now, when they want to assess whether they will just grant you loans or not, like there is an automated system that is really doing this for you. So let's assume that Anna has an annual salary of $40,000. She applies for a loan, and then her application gets rejected. Because this is an automated decision making, then one way to make the system ethical would be to ask the system to explain why Anna is rejected. And then the system assumes that generates the following explanation, says that Anna is rejected because her annual salary is $40,000. If her annual salary had been $80,000, then her loan application would be accepted. So assume that the system is generating this kind of explanation. Now, the challenge is it a really good explanation? Is it valid? Or should we really say that, okay, perfect, so now we have to encourage and admire these kinds of systems because they are explainable. So they make things very clear. And so now all of the banking systems or many other systems who are making such sensitive decisions now are ethical, and therefore should be kind of allowed to be used, and their use should be more expanded. And then maybe some computer scientists or some people who are dealing with technologies, they would basically on the first round say, yeah, perfect. So we have achieved an ethical system because it is kind of giving us explanation. So we have an explainable system. But on the other hand, maybe this explanation actually just tells how the system is working. It doesn't really say the real reasons, the real institutional reasons that has been put into work with respect to training data sets and etc. And therefore, this explanation might not really sound or might not really be a very good explanation although it might be true, or although it might say how the algorithm locally has made this particular reason. So hopefully these two examples that I gave, the principle of fairness as one ethical principle, the principle of explainability as another ethical principle for AI systems, has justified the significance of this translation problem, and hopefully it has revealed the importance of interdisciplinary collaboration between humanities, social sciences, laws, and computer science in finding some suitable answers to these translation problems. Thank you.
Thank you, Atoosa. In fact, thank you to all our three panelists, because I think those have been very stimulating short discussions, and they have indeed stimulated questions already. And I'll just remind those of you out there, if you want a question put to any or all of our panelists, please use the Q&A feature in Zoom. I'm going to go for our first question to one which has been asked of all the panel, and I'll ask perhaps Will and Tiberio and Atoosa in that order to answer briefly this one. This one comes from Graham Jefferson. Hello, Graham. Along the lines of the fruits of the poison tree doctrine, must we, for ethical reasons, not use AI that has been developed in circumstances that are inconsistent with our values? For example, is it not wrong to use an AI that has been trained on data sets that have been procured in breach of human rights, including privacy principles? And if so, is it not then inevitable that the best AI will accrue to those jurisdictions with the worst practices? Will, first, did you want to have a go with that?
That's a very good question indeed. It's a good question because it's a hard question. Obviously, different countries with different values are creating their own advanced technologies, and I'm thinking, of course, of in the Asia Pacific region, China, which has an extraordinarily advanced information economy and a very different attitude to the balance of individual and group rights to countries like Australia. Do I think it's wrong in all circumstances to use AI which has been developed in breach of human rights? I think the question is always one of what human right has been breached, what is the benefit of using the relevant technology, and how do we as a society answer those questions? I'm not, luckily, a moral legislator on my own. And tying it back to my talk, the most important thing to do is to begin engaging the major political institutions of our country in answering those types of questions. And the best way to force that to happen is by a general rule that algorithms and AI systems must pass some kind of a human rights audit or a human right risk impact assessment before they can be used, so that those types of trade-offs, those very difficult trade-offs, can be made public and can be acceptable to our society as a whole. I'll pass over to my other panelists who have much better things to say about this than me, I suspect.
Well, I don't really. I actually couldn't agree more. I think I'm very skeptical of unconditional normative statements, saying the all is wrong to do this, all is wrong to do that. I'm very skeptical of that, because sooner or later you can always come up with a counterexample to that, and where are you then, right? So I think we'll really hit the nail there. It's all about context, all about trade-offs, it's all about understanding the consequences of the use of this technology in a particular scenario, right? Because sometimes the actual consequences driven by the system may, according to some ethical framework, well offset some potential wrongness in the processes used to create the system. And then you have to actually contend with that trade-off. How do you sort that out in general, as a universal rule, as a Kantian categorical imperative? I just don't think that is actually feasible in practice. I think these questions are really complex, but I agree with Will. I think that using, for example, a baseline like human rights legislation, which are pretty universal principles, and trying to figure out ways to assess these systems against these principles is really fundamental. But well, the challenge, of course, is that we get into the problem that Atoosa pointed out. We don't really yet understand very well how to translate these complex concepts like fairness, like explainability, and so on, into the language that's required. But work needs to be done. It is possible. Progress is being made. We need to keep working on that, and I fully concur with Will on his assessment there.
Atoosa, do you have anything to add?
Maybe just a small note about privacy. Totally agree with Will and Tiberio. I think they basically mentioned my also point of view. But I think, again, with respect to the notion of privacy, and again, we need to think about what do we mean by a breach of human privacy. So again, there are many different definitions for privacy. In 1970s, people were giving definitions of privacy, the right to be left let alone. Of course, we are not, this notion of privacy is not really respected when we assume that Google, for example, is having access to our browsing history, or if Google Map is kind of activated, Google knows much better than us what I did or where I have been 3 years ago on this particular day. But then there is another conception of privacy as the notion of autonomy, like whether we would have, our privacy would be preserved if and then we should be autonomous. Again, that notion of privacy maybe would never be, in a very extreme case, be kind of preserved, because at some point these technologies have access to some of our data. But then in computer science, people talk about the notion of differential privacy, which means like extracting information about a particular group of people without pointing to one particular person. From a philosophical perspective, you can say there are some problems, some implications, some negative implications on the notion of human freedom and human dignity, if you really think that is an appropriate notion of privacy. But on the other grounds, there are some good arguments to be made that why we have to respect this notion of privacy. So again, it's very important to have like public discussions among different minds and different kind of disciplines to know what concept of privacy we have to really consider when we are using these AI systems.
Thank you all. Now the next question is directed to Will, and Trevor Mobbs asks, do you think that legislation authorising use of an algorithm is sufficient, or are you arguing that there needs to be legislative authorisation of the particular algorithm that's being used? For example, Trevor says, the issue with Robo-debt was arguably that the particular algorithm did not reflect the Social Security rules.
Thank you so much, Trevor. I completely agree with you. The issue with Robo-debt was that it was just very poorly designed, and it was designed in a way that was never going to meet the legal tests. My preferred solution is something like a public register, and that's accompanied with the default rule, which is a legislative rule, which is that if a government agency wants to exercise a statutory power through the use of an algorithmic decision system, that agency must register that it's doing such a thing. That agency must include basic pseudocode and a comprehensible plain English explanation of the way the algorithm operates. And if the basic rules are, if you don't register it, you can't use it. If you use it without registering it, your acts are invalid in the same way that any kind of government activity in contravention of legislation would be invalid. The reason I like, and so the question isn't, do we need to go to Parliament every time someone says, I've got a faster way to do back office processing? That's obviously preposterous. And we also don't need to go to Parliament every time someone says, hey, I've got a really intelligent way to work out which parts of society require a particular type of fiscal stimulus or a particular type of welfare benefit. But what Parliament needs to do is express a view in a way about the use of algorithmic systems in a way that ensures a baseline level of accountability for all types of algorithmic government. And in my view, that's best done by this type of register, which would let ordinary citizens, which would let the open source community, which would let ethical machine learners like Tiberio and specialist ethicists and philosophers like Atoosa understand exactly the way that government power is changing as a result of these extraordinarily powerful technologies, and in a way that creates a richer public discourse for us all. So that's the best answer I can give to the question. It's not really about authorizing an algorithm. It's about providing an ongoing and durable transparency and public accountability process for the use of algorithms generally.
Thanks, Will. Now, the next question is not directed at anyone, but I'm going to ask it of Atoosa because I think she might be well placed to answer it. So Olivia H asks, who should determine who's truly responsible when negative unintended consequences occur? Naturally, we could assume the primary responsibility lies with the creator of such automated systems, but what about systems that are closer to superintelligent behavior, example, DeepMind, when the creator no longer has autonomous control? Which actors are then needed to navigate these problems? For example, advocacy groups like Access Now or the ASPCR. What are your thoughts on the need for robot rights? Atoosa, did you want to address that one?
Yeah, thanks so much. This is a great question. So I personally like to think about the ethical questions of super intelligent entities and non-super intelligent entities, basically all AI systems that we have today, as two different problems. Although I have to say these two problems definitely converge, and ethical problems, some of the ethical problems of the current AI systems, the special artificial intelligence rather than general artificial intelligence, at the end of the day, like would become like very serious problems for general AI systems, like issues about safety, for example, or value alignment. The question about DeepMind or many other corporations such as Google is a very good one because these companies and corporations actually now have some divisions on ethics and society. There are some researchers that really are focused on working on making these systems kind of ethical. And so with respect to some conception of ethics, I think they have some algorithms, or some of the algorithms are ethical. So some of the ethical questions do not arise, for example, for AI systems that are used in gaming, or some of the AI systems that are used for example, the AlphaFold, one of the latest fantastic discoveries of DeepMind in like protein folding, like understanding some scientific issues. I think some of the ethical questions do not arise there. But for some other ethical questions, which are more questions about how these AI systems and the corporate and the expansion of these AI systems are changing humans, are changing society, they're changing our social life, then I think definitely those questions are not at all limited to the developers of the systems. And I personally think actually the developers are not able to answer to these questions because most of the time they've been concerned with other kind of technical questions about how to design an algorithm such that this algorithm is efficient and how to respect some complexity requirements and etc. So I think for sure, what has been started, like these public discourses among different interdisciplinary groups, is like the first step to go. And maybe later the world comes to the realization that they need to have some more serious organizations that take constraining and controlling these corporations and companies and algorithms more seriously. But you know, to be very honest with you, there is a very, very difficult challenge about how much we want to respect the freedom of research and the development of startups, and how much we want to have like regulations and ethical constraints. And where we want to draw the line actually is a very, very difficult question to answer.
Thank you very much. Now I'm going to direct the next question to Tiberio. It comes from Mark Brady, and if that's the Mark Brady I know, hello. And if it's not, hello anyway. Mark asks, how do you see the role of ethics in building trustworthy AI?
Right. Yeah, thanks, James. Well, that's a very big question. I can't make justice to it now, but maybe let me take one angle on that, okay? Which is really related to this. Let me talk about trust and trustworthiness. Now, trustworthiness is something you want for AI. I'm not a great fan of this expression, trustworthiness. You know, if you think of the mafia and some of your partners are very trustworthy, all that sort of stuff. So trustworthiness is almost like a morally empty sort of property. It just means like you got a handshake and you got to trust, you got to establish that. But the question of how do you actually incorporate ethics into reliable systems, you know, that actually deliver on their purpose. I like to frame it that way. So systems, practical systems, they need to basically deliver on their purpose. It's got to come from an understanding of what are the consequences of that system. What is that system doing to whom? Which harms it's creating? How it's distributing those harms? Which benefits it's creating? How it's distributing those benefits? Comes back to the question of power that Will was talking about. Comes back to the question of responsibility that Olivia asked about and that Atoosa was describing. You know, for example, the question of responsibility, perhaps an important question to ask is, why do you want to assign responsibility? What's the purpose of assigning responsibility? Well, one purpose of assigning responsibility is to create an incentive for the responsible party to actually not do the wrong thing, right? Right, so in other words, the element of trying to build safe, trustworthy AI systems, a large part of it is to actually hold accountable the parties that actually cause that system to be essentially present and making decisions about people. So, and let me challenge as well a little bit of this view around autonomous, you know, AI in the wild making decision about its independent of human supervision. That is, I would say, as a computer scientist and someone who has been working on this for 20 years, I'd say that this is not actually a very accurate view of what an AI system actually is. An AI system is something that is designed by people. It's designed by organizations. We understand much better as a result how an AI system works than how people work. We didn't design people. We actually have a lot of visibility of how an AI system operates, and we can shut them down and we can change their design. In fact, that's what I do for a job. I try to figure out how to incorporate these considerations of ethics, like fairness and transparency, and that Atoosa was talking about, but also how to figure out the causal effects, use causal theory and so on, causal inference, to figure out which configurations of your AI system will lead to which consequences, for whom. All these questions, we can have a handle on that because we are the ones who build these systems. They don't have an agency of their own. And this actually is a misunderstanding that the media often propagates. It's just not how the world works, how AI systems work. And just to finalize on that, what I find really challenging is when you get multiple parties, multiple organizations and institutions, and actually evolving naturally a system that has no legitimate central control, like what, for example, the internet is a case in point, and many of these systems that allocate, you know, ads in front of in your web page. You know, the complexity of the causal chains behind this is just beyond understanding. That is very complex because to actually change those things, you may have to take very more like fundamental interventions at a global scale as opposed to a local scale.
Thanks, Tiberio. We have many more questions, but I'm afraid we have run out of time. And so my apologies to Joanna and Mark and Riley that we didn't get to your questions, but thank you for asking them. Can I thank you all for joining us for this evening's event? I'd especially like to thank our expert panel, Will, Tiberio and Atoosa. Can I remind you all that the video of this event will soon be available on the ANU College of Law website. And while you're there, don't forget to join the mailing list so you can stay up to date with future events just like this one. So thank you again. Thanks everyone, and good night.
Thank you all so much. Good night.